Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. In today's presentation, we are going to discuss foundations of AI, applications of AI, problem solving in state space search. Let's see one by one. The foundations of AI. The first one, what are the foundations of AI? Let's look into this: mathematics, neuroscience, control theory, linguistics. In the mathematics, there is a formal logic and uncertainty. We'll discuss these two in the next videos. But what is formal logic? Here we'll use this Boolean logic, that is true or false, Boolean logic, and fuzzy logic. So in Boolean logic, true or false, we know that, and fuzzy logic means partially true, partially false. Uncertainty, it will solved by using the probability theory, and temporal and modal logic. These are the basic foundations of mathematics: formal logic and uncertainty. In formal logic, Boolean logic and fuzzy logic. Boolean logic means true or false, and fuzzy logic partially true and partially false. Uncertainty means there is some incorrect information, that is solved by using the probability theory and temporal and modal logic. Next one is neuroscience. This neuroscience means it is the study of brain. So here, in the early studies, they have used the injured people or abnormal people to study which part of brain is working on a thought. And nowadays, in the recent studies, they have taken accurate sensors to study which part of brain is working. So this thought process is very important. If you see, by using this thought process, the monkeys also can handle the mouse of a computer. And now, in the current scenario, how far we are to prepare the mechanical brain. The main aim of the artificial intelligence is make machines which are act like a human, think like a human, and perform rational things, which exhibits all this human behavior. That is called as artificial intelligence. Already we have discussed in the previous video. So here, how far we are to prepare the mechanical brain. That is neuroscience, which is the study of brain. The next one is control theory. This control theory means machines will change their behavior based upon the environment. And here the examples are thermostat, water flow regulator, and steam engine governor are the examples. For this, there is a feedback system in the 1984, and here it will transfer from the start state to goal state. How it will transfer from that start state to goal state, it will be derived, and it will be create the machines which will take the minimum energy. The next one is linguistics. It is about the speech which demonstrate the intelligence. If you see, the children will make a sentence, they are never heard about that sentence, even though they are able to form the sentence with the intelligence of the brain. The linguistics means it is a speech, and this is a language and that thought are the intertwined. The language and thought process are the intertwined. This language, if a man or a person will speak something, then only we can able to understand how much of intelligence he is having. So without his expression, without his exhibit something, we can't analyze who he is, what he is. So the foundations of AI is mathematics, neuroscience, control theory, and linguistics are the basic foundations of AI. Next, we'll see the applications of AI. So there are multiple applications are there. In that, some of the applications are business, engineering, manufacturing, medicine, education, fraud detection, object identification, space shuttle scheduling, information retrieval. So in the business, it will give some suggestions, financial advices in the business field. In the engineering, the prototype design and some models design, it will be suggest. And manufacturing, assembling, what kind of things which is has to use. Medicine, it will diagnose the disease and prescribe the medicine. Education, how it will be. Fraud detection, object identification, all these are the applications of the AI. The next session is problem solving. The next slides are. So what is problem solving? This problem solving is a method deriving the solution steps beginning from the initial state to desired solution. And here it is called as the state space. In AI, the problems are called as the state space, where the state space contain the all possibilities of ways to solve the problem. So the state space is a set of all possible states from start to goal state. There are two types of problem solving methods, that is a general purpose method and the second one is a special purpose method. General purpose method means which is applicable to various problems. Special purpose method means which is a specific domain. So under general problem solving, there is a production system and state space search. In this production system, it is the search process more conveniently in state space problems, which is give the more convenient to solve the problems. So this production system comprises start state, goal state, along with one or more databases consisting of suitable and necessary information to the particular task. And this information organized by using the knowledge representation schemes. So this production system consists of number of production rules which are used to solve the problem. Each production rule has a left side. The production rules contains like this. The left side is the rule which is going to apply on the current state. The right side rule is after applying the left side rule, what is the outcome? That is the right side rule. The left side rule is the current state and right side rule is the new state. That is what here. The rule has left side that determines the applicability of the rule and right side that describes the action to be performed if the rule is applied. Left side rule is the current state, whereas the right side describes the new state is obtained from the applying the rule left side. So these production rules operate on the database that changes the rules are applied. Dynamically, the database will changes. The production system also contains the control strategies, which means sequence in which the rules are applied when several rules are matched at once. There are two rules are similar rules and which these two rules are matched to apply. Then it will take sequence of rules and it will identify one of the rule and it will apply that rule. So example is expert systems. Let's see the advantages of production system. Here it is a strong state driven nature of intelligent action and it will derive the new rules without disturbing the rest of the system. Already existing rules are there. Without disturbing that, this will provide the new rules, and it is a quite important real-time environment and applications where new input to the database changes the system's behavior. Means when we are adding the new rules, then it automatically changes the behavior of the system. These are the advantages of the production system. Let's see the example problem, that is water jug problem. Let's see problem statement. Here the problem statement is there are two jugs. One is a 5G jug, 5 gallon, and another one is 3G jug. There is no mark on the jugs, and we need to fill the 4G water into the 5G jug. There is a 5G jug and one is a 3G jug. There is no mark saying that 1G, 2G like that. There is no mark on that jugs, but we need to fill 4G water into the 5G jug. Initially, these two jugs are empty. So the start state is 0, 0. Okay. The goal state, what is the goal state? There is no recommendation of 3G jug. There is no saying that. But in the 5G jug, it definitely should be 4G water, and 3G jug, it can be empty or it can be some water. There is no description about the 3G jug. That is the problem statement. We have two jugs, 5 gallon and the other 3 gallon, with no measuring marker on them. There is endless supply of water through gap. Don't worry about the water, whether we are wasting the water. No, don't bother about that. But we need to find out the optimal solution with the minimum steps. Water through tap. Our task is to get 4 gallon of water in the 5G jug. That is what I said. And there is no specification about the 3G jug. Either it will be filled with the water or it will be empty. Let's see what are the operations we can perform on the two jugs. We can fill a jug completely, or we can empty the jug completely, or we can transfer the water from one jug to another jug with receiving jug is full. So these are the three operations. Either we can fill, or we can empty, or we can transfer the water. That are the three operations we can perform. Next, representation. So we can represent the 5G with the X and 3G with the Y in tuple. These are the tuples. The initial state is 0, 0. Goal state is 4, 0. I already said in the production system, there are production rules are there. Left of the rule, right of the rule, description about that rule. The left side rule is the current state. The right side rule is the new state. After applying the left side rule, what is the outcome? That is the new state. And this is the description about applying the left side rule. Okay. And these production rules are if rules, if condition rules. Let's see one by one. There is a X, Y. X means I already said that is a 5G jug. Y is a 3G jug. Remember that one. If X, Y, then X is less than, there is a 5G jug. X is less than 5. Then fill the 5G jug. Already I said there are three operations, that is filling, next empty or transfer. These are the three conditions which we are going to perform on this problem. So if X is less than 5, then fill the jug. That is, when we fill, the new state is 5, Y. Y is empty, means it is not filled anything. So 5, Y. The second one, if X is greater than 0, then empty the 5G jug. If 5G jug is filled with the water, what we can do? We can empty the jug. That is what here the second rule. And third rule is Y is less than 3. It is similar to the first rule of 5G jug. So if Y is less than 3, if it is empty, then we can fill the jug. That is one operation we can perform on that. Next, if Y is greater than 0, then empty the 3G jug. If the 3G jug is filled with the water, what we can do? We can empty the jug. These are the four initial rules, that is filling and emptying. The rest of the four are transferring the water from one jug to another jug. Let's see. If X plus Y is less than equal to 5, if X plus Y is less than equal to 5, for example, X is some X means 5G jug contains a 2G water plus Y contains 3G water. Then 2 plus 3 is less than equal to 5. It is equivalent. And also Y is greater than 0. Y contains already 3. So Y is greater than 0. Then we can apply this fifth rule. Empty 3G water into 5G jug. So we can transfer the water from 3G into 5G jug. Next rule, x plus y is less than equal to 3. For example, x is 1 and y is 2. Then 1 plus 2, 3. 1 plus 2, 3. 3 less than equal to 3. Then, and also x is greater than 0. Already x contains 1G. So, x is greater than 0. We can transfer the 5G into 3G jug when this rule is applied. Next, if x plus y is greater than equal to 5. For example, in x contains 3G and y contains also 3G. 3 plus 3, 6. 6 is greater than equal to 5. Then what we can do? Pour water from 3G into 5G jug. We can transfer the water until 5G is full. Pour water from 3G jug into 5G jug. Let's look at this one. 5 means after filling from the 3G into 5G, the x contains 5, comma, y is 3 minus 5 minus x. How much water we can pour into the 5G jug? That is 5 minus x. Already x contains 3. So, 5 minus 3, 2. 3 minus 2. It contains 1. Here, 5, comma, 1. For example, x contains 3, y contains 3. This 5G contains 5 and 3G contains 1. Next, similarly, x plus y is greater than equal to 3 and x greater than 0. We can transfer the pour water from 5G into 3G until 5G jug is full. This one is also similar to this 7th rule. So, these are the production rules. The production rules where we can apply these rules on the problem state, which we can get the desired goal, desired solution. Whether this production rule is required to solve or not, it doesn't matter. First, we need to form all the rules what we can apply. Let's see the problem solution statement. So, here we have taken rule apply. What kind of rule we applied? These are the rule number and 5G jug, 3G jug, step number. After applying the rule, whether it is empty or whether it is full, we have written all this and how many steps we have taken to solve this problem. So, the start state. What is the start state? 0, 0. Initially, it is empty. What is the goal state? It is a 4G water and a 3G. There is no description about that. So, first, initially when it is empty, what we can do? We can fill the water. And now, here I have taken first rule. You can take the third rule also, filling the 3G jug. One problem can have multiple solutions. In this case, I am filling 5G jug. You can fill the 3G jug and we can solve that using 3G jug also. So, let's see the first one. We are applying the first rule. By applying the first rule, what is the first rule? Here, fill the 5G jug. After filling, what happens? 5, 0. Okay. The 5G contains 5 water, 3G contains 0. Step number 1. Next, what we can do here? This one is 5G and this one is 3G. So, already 5G is filled with the full of water and 3G contains the empty. So, what we can do? Either we can fill the water in the 3G or we can transfer the water from 5G into 3G. So, here we have taken transferring the water from 5G into 3G, where we are having that rule, pour water from 5G jug into 3G jug until 3G jug is filled. So, applying 8th rule. What happens whether we will take the third rule, filling the 3G jug? The both are full. 5G is full and 3G is full. So, we can have only one option, that is emptying the jugs. So, that is not applicable to reach our goal state. That's why we have taken the 8th rule, that is the transferring the water from 5G jug into 3G jug. So when we transfer the water, the 5G jug contains the 2G water and 3G contains the 3G water, and this one is the second step. So here we are having 2, 3. Next, what we can do after containing the water in the 2G water in the 5G and 3G water in the 3G. So either we can fill or we can empty. These are the two rules. Already we have transferred the water. What I am doing, we can empty the water by using fourth rule. Empty the 3G water. So after emptying the 3G water, the current state is 2, 0. The step number is 3. Next, what are the next operations? Either we can fill the water. If you fill the water, what happens? It will goes to the previous state. So don't do such things. We have to transfer the water. After transferring the water, to transfer the water, look at the sixth one. Empty the 5G jug into 3G jug. So we need to empty. That's why we transfer the 5G water into 3G water. Then the next state is 0, 2. Okay. So in this state, what we can do? We can fill the water into the 5G jug, or we can transfer. When we transfer the water, what happens? Again, it will goes to the previous state. That's why we will fill the water by applying the first rule. Then 5G contains the full water and 3G contains the 2G water. Now what we will do? Here it is a 5, 2 is the current state. Now we can transfer or we can empty. When we can empty, it will reach to the previous state. That's why we can transfer the water. So here again we are applying the 8th rule by transferring the water, because x plus y is greater than equal to 3. So look at this one. 5 plus 2 is greater than equal to 3. Transfer the water from 5G into 3G. Then we'll reach the desired goal, that is already 3G contains the 2G water. We can transfer until 1G water. So the 5G contains 4G of water and 3G contains the 3G of water. 4 and 3 is our desired goal. Okay, let's look at the visualization pictures. 5 liter and 3 liter. Step 1, filling the 5 liter water. Step 2, transferring the water. Step 3, emptying the water. Step 4, transferring 2G water into the 3G water. Step 5, filling the 5G water. Step 6, transferring 5G water into 3G water so that we can reach our desired goal. So in this presentation, we have seen the foundations of AI. So what are the foundations? Mathematics. The basic foundations of AI was mathematics, neuroscience, and next one is linguistics, and last one is control theory. These are the foundations of AI. Next we have seen applications of AI. There are multiple applications are there. In this, we have seen multiple business, fraud detection, engineering, medicine. Okay, these are the applications. And here there are two views of AI. Two views of AI. The first one is AI is about to duplicating. AI is about to duplicating what brain do or what brain does. What brain does, which is a cognitive science. Next, what brain should do. Brain means human brain only. What AI is about duplicating, what brain should do. Okay, this means rationally, without following the emotions of a human, logically, what kind of things it can do. It can do lot, but we can do only some. By thinking power of the human, we can do only limited things. That is the two views of AI. According to AI view, the first one is AI is about duplicating what brain does. That is a cognitive science. The second view is AI is about duplicating what brain should do. That is rationally doing things. The last one we have seen problem solving definition. That is the description about the beginning of the problem to the desired solution. Will apply the control strategy, means order of rules to solve the problem to the current state. In this we have seen one problem, water jug problem. In the next session, we'll see state space search, followed by the exhaustive searches. And here, whatever content I am delivering, I am following Saroj Kaushik. Thank you.